Hello students, we were doing preparation of aryl halides. Two methods we have done already. That was direct halogenation of benzene ring, and the second was by the side chain halogenation. Now we are taking the next method for the preparation of aryl halide, and that is from diazonium salts. Diazonium salts, students, what do we mean by diazonium salts? Diazonium salts possess N2 positive group, N triple bond N 1 positive if present. That means we are talking about diazonium salts. Here these diazonium salts are prepared when aromatic amines are treated with HNO2, that is nitrous acid, and hydrochloric acid HCl at temperature 0 to 5 degree. Why I am giving stress to this 0 to 5 degrees Celsius? Because these aromatic diazonium salts which we are preparing are stable only at this low temperature. If temperature is raised, these get highly unstable and cannot able to exist. That's why whenever we are preparing diazonium salt, we have to mention the temperature, otherwise they will not able to be stable. They will not able to exist. Okay, so here as we are firstly preparing diazonium salt, and after that by using this diazonium salt we can prepare haloarenes. So here how to prepare this diazonium salt? C6H5NH2, HNO2, that is nitrous acid, HCl. Here what is happening, students? I have written here that H2O, one molecule, water, and the second molecule of water, H2O, getting eliminated. Two molecules of water are getting eliminated, and this N is getting attached on this benzene ring in the form of N2, 1 positive. Why 1 positive? Because as you know, students, nitrogen is having 3 valency, 1, 2, 3 already there. One more side it is if getting attached, that means it will acquire 1 positive charge. So N2 1 positive and Cl1 negative. So this is called benzene diazonium chloride. Now we will use this benzene diazonium chloride for the preparation of haloarenes. Okay, students, how to prepare that haloarenes? So haloarenes, if we are preparing by using diazonium salt or benzene diazonium chloride, the reaction is called Sandmeyer's reaction. Students, very important reaction. Again, I am telling you that named reactions are very important. Sandmeyer's reaction, what is it? Here I have taken this C6H5N2Cl, that is benzene diazonium chloride. If treated with HCl in presence of cuprous chloride, Cu2Cl2. Here we can take any cuprous halide, students, and halogen acid. So here I have taken HCl and Cu2Cl2. So product we are getting is C6H5Cl. This Cl is getting attached over this benzene ring. Nitrogen is getting eliminated and this Cl is getting attached with H. So we are getting HCl and N2 along with haloarene or chlorobenzene. Second, I have taken here, students, the same benzene diazonium chloride when reacting with HBr this time. Instead of HCl, I am taking now HBr. If HBr I am taking, here the catalyst which we are taking is Cu2Br2. Cuprous bromide here I am taking. So in this case, this bromine or the bromide ion get attached over the benzene ring and we will get bromobenzene along with the formation of HCl, this HCl, and nitrogen gas eliminates out. So this is called Sandmeyer's reaction. One more thing here I am telling you, students, for the preparation of iodobenzene, no need of any cuprous chloride or catalyst is required. Direct this Ki or NaI can react with diazonium salt to give iodobenzene. Here Ki, when reacting, we will get KCl, N2 will release out an iodide ion get connected over this benzene ring. So we are getting iodobenzene, nitrogen evolving out and KCl is forming. So in this way, we can prepare iodobenzene directly without the presence of cuprous halides. One more thing, students, as I am telling you again and again that for the preparation of iodo and fluoro, some different methods are there. So now I am taking preparation of fluorobenzene. It is very, very important, students. And the special method for fluorobenzene preparation is Balz-Schiemann reaction. Balz-Schiemann reaction. Balzschiemann. Balz-Schiemann reaction for the preparation of specially fluorobenzene, fluoroarene. What is done in this? Again, I am taking this disonium chloride or disonium halide and it is reacting with fluoroboric acid. This is HbF4, which is fluoroboric acid. When it is reacting with disonium chloride, HCl is releasing out and this BF4 is getting attached with this N2. So here a intermediate complex we are getting. Before getting the final product, we are getting some intermediate. And on heating this complex, what we are getting? N2 is again evolving out. BF3, boron trifluoride we are getting. Here BF4 is there. So one fluorine is getting attached with benzene ring and we are getting fluorobenzene. So in this way, by adopting special method that is Balz-Schiemann reaction, we can prepare fluorobenzene. Okay, students. Otherwise, direct fluorination is highly vigorous, become out of control. That's why for the preparation of alkyl fluoride or aryl fluoride, some special methods are used. In the case of alkyl fluoride, students, we used Swartz reaction, if you remember. And for fluoroarene, we have used Balz-Schiemann reaction. Now, one more reaction I am taking, students, again name reaction after Sandmeyer's. It is very similar to Sandmeyer reaction and that is also called modified Sandmeyer reaction. And the name is Gatorman reaction. What is it? In the Gatorman reaction, here instead of cuprous halides, we just take copper powder. If cuprous halide is not, in this case of Gatorman reaction, cuprous halides are not taken. Here we are directly taking copper powder only. And rest of the reaction is same. Like C6H5N2Cl, only the copper powder is taken and halogen acid. And that halogen acid is providing that halogen from it. And here we are getting chlorobenzene plus nitrogen gas evolves out. In case of bromobenzene, students, again C6H5N2Cl, here copper powder is there, HBr is reacting with it. So now this time Br is getting attached with benzene ring, nitrogen gas evolves out and HCl is the byproduct. So in this way we can prepare different aryl halides by Sandmeyer reaction and by the Gatorman reaction. One more reaction, students, I am taking, which we took in the case of alkyl halide also, that is Hunsdicker reaction. Hunsdicker reaction, in that we took silver salt of fatty acid. Here I am taking C6H5COOAg. There we took RCOOAg, where R was the alkyl group. Here I am taking R as aryl group, RCOOAg. So C6H5COOAg is when reacting with bromine in presence of CCl4 as a solvent. What we are getting, students? C6H5Br, that is bromobenzene, CO2 evolving out, and one Br is getting attached with silver to get AgBr. So this is another method for the preparation of haloarene Hundsdicker reaction. Okay, students, so these all were the preparation for haloarenes. Now we are proceeding towards physical properties of alkyl halides or aryl halides. First of all, I am taking state in the physical property. State, it is colorless liquid. Generally, all the alkyl halides are colorless liquids. Why I am using generally word? Because alkyl bromides or alkyl iodide, if comes in the contact with the atmosphere, they acquire some color. Okay, but generally they are colorless liquids. Then I am taking the solubility. Friends, it is very important. That's why I have put one star here. You have to do this property, that the solubility, if we are taking, they are insoluble in water. As we have done, students, that like dissolves like. And we have done that alkyl halides are polar. Why they are polar? Because of presence of CX bond. CX bond, where X is negative and this carbon is slightly positive. That means if they are polar, due to the presence of charges, they are polar, and if they are polar, they should be soluble in water, but they are not. Why they are not soluble in water? So question can come, though alkyl halides are polar but insoluble in water. Why? So reason is, these alkyl halides cannot able to form hydrogen bond with water. That's why they are insoluble. Okay, students, alkyl halides cannot able to form hydrogen bond with water. In short, I am telling you, students, and that's why they cannot able, that's why they are not soluble in water. Okay. Next property I am taking is boiling point. Remember that, students, since alkyl halides are polar, they possess dipole-dipole interaction, or they are also possessing van der Waals interaction. And that's why, due to the presence of dipole-dipole interaction, they have higher boiling point than their parent hydrocarbon. Simply, if I am taking CH4 and if I am taking CH3Cl, so CH3Cl will be polar. That's why the boiling point will be more here in Rx than the parent hydrocarbon. Now, different features, different properties also affects the boiling point. Here I am taking that factors one by one as the size of R increases. Like first time I am taking methyl, ethyl, propyl, butyl. As the size is increasing, more will be the van der Waals force of attraction. And remember, students, as the van der Waals force of attraction is increasing with increase in size, boiling point also increases. So remember, students, that if R size is increasing, boiling point also increases. Clear? If suppose the size of R is same number of carbon atoms if present, but different isomers are there. Like if suppose I am taking chlorohexane, or here I have written halohexane. So halohexane, you are observing that 6 carbon atoms are there which are attached in straight chain. And same 6 carbon atoms here I have taken in the form of 2 branches. This is the straight chain, 1 carbon above, 1 branch is above side and 1 is this side. So 2 branches are there with this carbon at this carbon. So what is happening if we are increasing branching? On increasing branching, remember that surface area decreases. And if the surface area decreases, boiling point also decreases. So here if we compare the boiling point of these two isomers which are having same molecular formula, so this will be having more boiling point. Why? Because of more surface area. So here I have written, students, that if branching increases, surface area decreases, and if surface area decreases, boiling point also decreases. Remember this point, students. Question can come over this. Now if again I am saying that alkyl group is same, but the size of halogen is increasing, boiling point also increases. Here I have taken one example, C2H5Cl, and here C2H5I. The size of iodide is more than the chloride ion. That's why this alkyl iodide will be having more boiling point. Again the same case, size is more will be the van der Waals force of attraction. Here if I am taking number of halogen if increasing, again boiling point increases. Here also I have taken some example like CH3Cl. Here one chlorine is there, alkyl group is having one carbon. In the next alkyl group of one carbon is there only, but Cl number is 2. Here that Cl number is 3. So maximum be the boiling point in this chloroform, or CHCl3, then CHCl2, and least in case of CH3Cl. Next is, as we are knowing that alkyl halides are polar, but polarity of alkyl halide decreases with the decrease in electronegativity. Why alkyl halides are polar? Because of electronegativity difference between carbon and the halogen. And as the electronegativity of halogen decreases, like fluorine, chlorine, bromine, iodine, electronegativity decreases. So polarity of alkyl halide also decreases. Here I have given you example, students. Like CH3F, you are observing that instead of decrease, here it is increasing. So this is only the exception case. This alkyl chloride is having maximum polarity, and then you are observing that in case of bromides, in case of iodides, it is decreasing. So this, I will tell you the reason that why this fluoroalkane is having lesser polarity. Here, why this CH3Cl is having maximum polarity. So mainly what we are doing, that polarity decreases with decrease in electronegativity. So we have done, students, today all the physical properties. Then in the next video we will take chemical properties, students. Do these all properties nicely. This boiling point and the solubility property is very important, students. And I am repeating again and again that please do all the work in your fair copy, students. Keep your copy up to date. Okay, students? Okay, thank you.